Hi folks, this is Karim Raouf for IT Visualizer channel. We will continue our lab, the matrix lab, the video number 135. We have been discussing in the previous video the following. We are still working with the topic of troubleshooting Windows using Microsoft Sysinternals suites. We have seen how the AI Claude 3.7 Sonnet generated a lot of scenarios and a lot of scripts to utilize the using of different Microsoft Sysinternals suite tools. We have talked about PS tools. We have talked about Process Explorer, Process Monitor, a lot of things actually, and we have seen how they are very useful, and we have seen that there are some cases related to using these tools from a PDF called Troubleshooting Using Microsoft Sysinternals Suite. This is created by the creator of the tool, Mr. Mark Rodenbench. I hope I pronounce it right. So what I have did a couple of videos ago, I asked the AI tools or ask Claude 3.7 Sonnet to get these cases or extract these cases from the PDF and then try to explain it in his own words. So we have seen how about 10 cases, as far as I remember, related to using Microsoft Sysinternals suites to solve them, and this was listed or was published by the creator of the tool. So this gives it more credibility, and through it he explained how he use his tools to solve these problems. So today we will continue with the cases also related to or was extracted from his PDF or the creator of the tool. He also made a PDF to explain his tools. Anyway, so let's continue with case number 11, the failed forest functional level raise. This case involves Active Directory. Administrator was unable to raise the forest functional level from Windows 2000 to Windows 2003. We have seen these cases are a little bit old because I think the tools was created a little bit far ago. Okay, so receiving an administrative limit exceed error. What tool would help with Active Directory issues? Add Insight or Active Directory Insight is perfect for this. It monitors LDAP calls between applications and Active Directory. This is the protocol used to communicate between Active Directory and different applications. So for example, if you need to extract something from the Active Directory users or groups and export them to Excel sheet, you actually could use LDAP for that. Anyway, Lee demonstrate using Insight or AD Insight to capture the error. Let's capture LDAP traffic while reproducing the error. So he will do the raising of the forest functional level, and then he is using AD Insight to monitor this operation, okay, which uses LDAP protocol, okay, or LDAP traffic, okay. After capturing the trace, Leo uses AD Insight, go to the next event error button. So I think let me go to AD Insight. I think this is it. If we go to that and we open like this, and we have Sysinternals suite, and we have AD Insight. Which one of these? We have one for the 64-bit. So if you run it as Explorer, run it as administrator, agree. See here, I think we will capture events. Here is capturing the events, and as far as I see from from the scenario, he is capturing the events. Here is the MR admin limit exceed on a modify request for the configuration parameter container. I think this is a section in the Active Directory database related to maybe forest functional level. Okay, what does this mean? It means there is a limit being exceeded when trying to modify an attribute. Let's examine this container in ADSI Edit. This is another tool. You can explore Active Directory parameters or schema using it. They check the object attribute in ADSI Edit. Look at that. The UPN suffix attribute has 970 values. At the Windows 2000 functional level, Multi-valued attributes are limited to approximately 850 values. So it couldn't update the forest level because it couldn't properly modify all of these values exactly. The solution is to reduce the number of values in that attribute to below the limit, then try the operation again. They demonstrate the solution working. AD Insight was helpful for identifying exactly where the LDAP operation was failing. That's right, for Active Directory issue, it gives us the visibility into the LDAP operations that we wouldn't otherwise see. So he is talking about that AD Insight is a tool that will capture uh, uh, things related or errors related to the Active Directory. So this is like a live capture of the events of the Active Directory, maybe. So I think this could be a good thing. Okay, so we will close this one. So let me here go do thing here. If we take this case and try to simplify it more, so we will take this case, okay, and try to simplify it more. If we go there and try to go to this and take that copy and try to ask Grok to explain this case in layman terms and include glossary or glossary for terminologies. So let's see if this he can explain it in uh, uh, much better format. We can do like this. We have Control A and Control C, and then we can do that. Now we can go to ChatGPT and do the same. As for Gemini, it a little bit uh, over explaining, or it tends to get to give more text in his response. So let me do it like this and try to also give him this prompt, and let's see how this will be explained. So here have took about 29 seconds for thought. Explaining case 11, the failed forest functional level raise in layman terms. Imagine you are managing a huge address book for a big company computer network. This is the Active Directory. This address book called Active Directory keeps track of all employees, their computers, and other resources so everyone can log in and access what they need. One day, the person in charge, the administrator, tried to update his system from an older version, Windows 2000, to a newer version, 2003. This is not the system version, the Active Directory version. Okay, this is the Active Directory version. This update, known as raising the forest function level, would unlock new features to make the network work better. So this is related to the Active Directory system from Windows 2000 to Windows 2003. But instead of succeeding, they hit a roadblock. An error popped saying administrative limit exceed. So what went wrong and how they fixed it? To figure this out, they use a tool called AD-Site. It's like a spy gadget that watches how the address book talks to the network behind the scene. This communication happens through something called LDAP, a set of rules the system uses to find and update information. Okay, they turned on AD Insight, tried the update again, and caught the error in action. The tool showed that the problem happened when the system tried to change something in a specific section of the address book called the configuration parameters container, or the configuration partitions container. Okay, a part that organizes key details about the network structure. Okay, the error called admin limit exceed, which meant they would bump it into some kind of limit. Next, they opened another tool called ADS Edit, which lets you peek into the address book and edit it directly, like flipping through pages and making notes. They zoomed in on the configuration partitions container and found a troublemaker, an entry called UPN suffix. This is a list of extra endings for employee logins like at company.com or sales.com. This is something like extra details uh, for entries in the Active Directory. It had 970 different endings. Here is the catch: in older Windows 2000 versions, lists like that called multi-valid attributes can hold only about 850 items. With 970, they are gone way too far the limit. So when they try to update itself to a newer version, it needed to adjust this list but couldn't because it was too big. It's like trying to stuff an overstuffed used suitcase in a tiny locker. It just wouldn't fit. The solution: they trimmed down the list of endings to less than 850. Once they did that, they tried the update again, and this time it worked perfectly. In short, the update failed because the address book had too many login naming endings, hitting an all system limit. By cutting the list down, they cleared the way for the upgrade. Tools like AD Insight and ADSI Edit were like detectives, helping them spot and solve the problem by showing exactly what was happening inside the system. So we can see here a couple of things: Active Directory, explanation, forest, functional level, LDAP, AD Insight, configuration parameter. A section of Active Directory holds the big picture in info about how the network is organized. It's like its domains and locations. Partition container, a smaller part inside the configuration partition that keeps track of different data sections in the network. UPN suffix, a list of extra endings for login names like at company.com, letting users log in with different options. Okay, multi-valid attributes, and a type of entry in Active Directory can store multiple items like a list but has limits on how many it could hold. So as we can see here, this is a very good explanation or simplification for the case. Let's see uh, how ChatGPT will explain that. So he's talking about uh, goat. So he's unfolded. So I think he's talking about the same thing but less creative. I think he's not uh, simplifying it. Okay. So Leo, okay, Synsight, okay, okay. I think no, this is not an answer that I can accept. Okay, it's not that simple. Okay, so if you go to Gemini, let's see how he will explain that. Uh, Again, we see there is a lot of text. Okay, but here is trying to explain it. Imagine your company computer network has a central brain called Active Directory. This brain controls user logins, computer setting, and overall network organization. Like software, the brain has different versions or levels. This is good. The administrator want to upgrade the network brain. Very good analogy, from an older version, 2000, to a slightly newer version, 2003, to enable new features. However, the upgrade failed with a confusing error: administrative limit exceed. This error didn't explain what limit was exceeded or why. This is a good thing. Okay, so we used a utility called AD Insight. Okay, finding the glitch. They tried upgrade again while AD Insight was listening. Okay, AD Insight pinpointed the exact moment the upgrade failed. It showed that the failure happened when the system tried to update a specific setting list stored deep within the Active Directory configuration. So he go to this part of the AD configuration. It's like using ADSI edit. It's like a powerful magnifying glass for AD data. They look closely at specific setting called UPN suffix. This list contained alternative endings users could use for the login like so. So this is like alternative login parameters. Okay, if he can log in, for example, like at company.com or mail.company.com. I think this is to log into multiple domains maybe, or different attributes for the users. Discovering the cause, they found that this list had a huge number of entries, 970. The problem was the old system level they were trying to upgrade from had a strict hidden rule. Lists like they could not contain more than about 850 items because the list was already over this limit before the upgrade started, the upgrade process could not properly handle or modify it. It causes the limit exceeded error and stopping the entire upgrade. Okay, so this is it. As the sum here was thing he already clean up the suffix by removing unnecessary or outdated entries. It had fewer 850 items. Try to upgrade to Windows Server functionality again. Okay, this time it was uh, successful. Why AD Insight was helpful? The standard error was too vague. AD helped me to see the exact hidden step, the attempt to modify the oversized list that was causing the failure, which allowed them to find and fix the real root cause. As you can see, here is the grocery. We can see here administrative AD Insight, the protocol. So I think also maybe the second best answer is Gemini. Okay, Grok is the first one, and the least one from my point of view is Gemini. For many, strange, I need for many high, not for many only. Okay, anyway, I think we can go to a new chat and get for all many high. Okay, for coding and reasoning. I think this is a good thing. Maybe the answer was not correct because the model. Let's try to see if we give him the same prompt again and see how he will explain that. I think the same message or the same explanation seems to be not good anyway. So we'll continue with case number 12, the failed AV update. The user's computer is completely unbootable after an antivirus update. It shows that the Windows XP splash screen and then blue screen. How you can fix this without reinstalling the OS? So this is on XP again. This seems to be an old case because these tools was created, I think, at the time of Windows XP. There is where autorun analyze offline system feature help us. We will boot from a recovery disk and use autorun to disable the problematic components. So let me see autorun here. If we go to the autorun, here it is. This is it, and try to see that. So here is the autorun. He is talking about a feature called uh, analyze offline system. This is it from the file. Where is it? Yes, we need to do that. Analyze offline system when we are so we will boot with a recovery uh, Windows recovery environment, and then we will use autorun to analyze offline system. Okay, so that's good. Okay, on the hard drive now we will see. So let's see how this will be solved. Now we can see all of the auto starting components from the unbootable system. We will disable the antivirus component first, since that was triggered the issue. They disable several entries related to antivirus software. Should we disable anything else while we were there? It's a good opportunity to clean up other unnecessary or outdated auto start items that might cause problems. Disable several more items and appear outdated or unnecessary. Now let's boot and see if the system starts. Normally the system boots successfully, it worked, the user can access the system again. Now they should uninstall the problematic antivirus completely and install a more reliable solution. Autorun saved us from having to reinstall Windows. That's incredibly useful. It's a lifesaver for boot issues caused by problematic auto start components. So simply he used the autorun to disable all of the entries related to the antivirus. So now they can boot safely. This antivirus update uh, uh, corrupted or cut or disrupt the booting process of the Windows. So it's XP flash screen and then blue screen, the blue screen of this. Okay, so just by disabling it, You can do this from the MS config, by the way, but I think autorun is more advanced. Okay, this is the antivirus case. Then we have the crashing proxy utility or proxy utility. The user has utility called proxy that worked fine for over a year but suddenly start crashing. Let's use Procmon to see what's happening just before the crash. So this is an application was used by a user and now it is not working. So we will run this utility, but before we will monitor or we will begin capturing uh, the whole process by using Procmon. They produce the crash while running Procmon. Let's look for errors in the trace leading up to the crash. Leo filters are successful operation. There is an access denied result when it tries to open a file with write access right before a debug handles the crash. So there is access denied. The program is trying to uh, open a file with write access. Maybe he's trying to write something to a file. Let's check the file properties in the Windows Explorer. Look at the General tab. The read-only attributes is checked. This would explain why the access denied result when trying to write to the file. So this user permissions on a file, but the user has full permissions to the file according to the security tab. This is a common misconception. The read-only attribute is separate from NTFS permissions. Uh, Separate to NTFS permission. Even with full NTFS permissions, the read-only attribute will prevent modification. So there is two permissions as far as I can comprehend. Maybe some share permission and or a SMB permissions and NTFS permissions. So he's saying that if there is two permissions, the least one will prevail. So I think this is it. So they clear the read-only checkbox. So let me try, for example, to get something like that. Maybe some file like this, and for example, let's go to any file, any simple file like this. Maybe something like light click and properties. See, it's talking about the read only. This is if I have full control and I have read only on it, this will so this is not an SMB. I think this is different. So this is attribute read only. So maybe this is the thing here. So he's talking about if this is listed or this is checked and we have here full control, this option will prevail or this will be executed. That's it. So let me see, this is talking about. So again, this is common misconception. The read-only attribute is separate from NTFS permissions. So this is not SMB share permissions as far as I know. Now this is another case. I don't know how it is categorized, but this is not SMB share permission, okay? But it will prevail even with full permission. The read-only attribute will prevent modification. So this is one thing to know. Now the program will work properly. The NTFS permission and the file attributes are completely separate systems. Yes, that's it. The file attribute and the NTFS permissions. So this is file attribute system and NTFS permission system. Yes, permissions control who can access the file, while attributes control how the file behaves regardless of who is accessing it. So this is another good info to consider. Okay, now we have case 14, the failed network location awareness service. Uh, Let me see case number 14, the failed network location awareness service. Administrator noticed the network location awareness NLA service was terminating shortly after starting with an event log error. I think this is where network location awareness, I think this is to know if you are in a public network maybe or private network or domain network. Let's continue with the scenario. What's our approach for troubleshooting services? We will use Procmon to capture the service startup and failure. The startup Procmon start the NLA service and wait for it to fail. NLA service just runs inside the SV host.exe process. So we first need to identify which svhost.exe hosted. There is a lot of files with this name. Which one is running this service? Okay, so Leo filters in procmon svhost, and then operation in is load image. The SV goes process loading NLA SVC. It must be the one. Okay, this is the one running the service. Now let's filter for just the process ID and look for errors related to this event. Okay, relating to this event. There is access denied error while trying to access the NLA SVC parameters registry key. Let's check the permissions on that key using regedit and compare them to our working system. Let's see, the permissions are completely wrong on this system. Someone must have modified them incorrectly. How do we fix it? We will set the permissions to match those on the working system. They adjust the permissions and verify the service now starts successfully. Other case where Procman quickly identified the access issue, it's getting easier to spot the patterns. That's right, many issue boil down to permission problems or missing dependencies. So this is, I think, this service, network awareness service. Let me see. I need to just have some or query about this service. Let's see if we go to perplexity. Let's see is what is in Windows. Let's see that. Okay, so as we can see here, this is the service key functions and purpose. So we can see there's a core Windows service that enables the operating system and applications to identify and respond to network environment a computer is connected to. Its primary function is to detect the current network location and provide this information to application and system components, allowing them to adjust their behavior and security setting accordingly. Key functions and purpose: network identification. NLA determines the logical network a Windows computer is connected to by analyzing network characteristics as DNS, domain name, subnets, and custom registry information. It helps the system recognize what it's a home, work, or public network. So this is it, the network profile. Dynamic configuration. Based on the detected network location, Windows can automatically configure firewall rules, security setting, and network sharing options. For example, stricter security is applied on public networks, while more permissive settings are allowed in private or domain networks. Support for roaming or multi-homing. NLA is especially useful for devices that move between different networks, a laptop connecting to Wi-Fi at home, work, or a coffee shop, or that have multiple network connections such as Ethernet and VPN or Wi-Fi and cable. It ensures the correct network location applied in each scenario. Application integrity. Application can register with NLA to receive notifications about network changes and query the current network location. This allows them to adapt, such as choosing whether to use a proxy server or accessing specific network resources. How NA works: they use a combination of the HTTP, DNS, and physical network interference data like MAC address to identify the network. Okay, it attempts to match the network to a known profile, network profile, or firewall profile, and assign the appropriate location type. Okay, firewall location type, public, private, or domain. Notification and caching. When a network change is detected, NLA notifies this application and system service. If detection fails, NLA caches the negative result and retries on the next attempt. Service name. The service runs under the name NLA service in Windows, and it is essential for proper operation of features like Windows Firewall and network dependent applications. So NLA is also a security feature. By distinguishing between public and private networks, it helps protect computers from potential threats on untrusted networks by restricting access to sensitive resources and tightening firewall rules. Practical impact: automatic profile switching. Okay, between private or public or domain, custom application behavior. Developers can build applications that respond intelligently to network changes, improving user experience and security. So we can see here NLA capabilities, network detection, dynamic configuration, application notification, security enhancement, roaming support. So as you can see here, in summary, it's a fundamental component that enables operating system and application to recognize the current network environment, dynamically adjust setting to optimize connectivity, security, and user experience. So where is this service? Let me see if I have it. So we have services. I think there it is in the services section. Okay. So this will be network. So here it is. This is the network location awareness. As we can see here, this is in the Windows and it is running as we can see here. And if we go to the scenario, so he's saying that there is an error relating to this service, and we have seen that this service is trying to access a registry key. We have access denied to it, so this is something related to this service trying to access a registry key, and it failed to do that, so this service was not running properly. So that's it. If we go and go to the next case, case 15, the failed EMET upgrade. I think this is an antivirus. Here's an interesting case. A user upgraded from Enhanced Vegetation Experience Toolkit version 3 to version 4, but now the application configuration utility crashes with requested registry access not allowed. What is Enhanced Meditation Experience Toolkit? Is this something? What is this application? Let's try to copy it and see if it is what is. So what is this case? This is, or this tool, a free security utility developed by Microsoft for Windows operating system. Its primary purpose is to help protect computers against common software explosion techniques, especially those targeting vulnerabilities in both Microsoft and third-party application. Key features: Unified Security Interface. EMT provides a central interface to enable and fine-tuning a range of Windows security features, making it easier for users administrators to apply advanced vegetation without needing to modify or recompile application. Application hunting. EMET acts as a protective wrapper around application, forcing them to use security defenses built into Windows, regardless of whether the original developer enabled those protections. No source code required. Protection against zero attacks. Okay, so this is the things he used to enhance Windows security. Use case: system-wide or pre-application. EMT allows vegetation to be applied system-wide or on a pre-application base, offering flexibility for compatibility and risk management. Legacy and unsupported software. It's especially valuable for protecting older applications that do not natively support modern security features. So this is a good one, but let's see here some notes. Release and support. EMT was first released in 2009 and supported on Windows Vista and later so and so. The final release was 5.52, released in November 2016. Microsoft ended support for EMAT on July 31, 2018. It's not compatible with Windows 10 version 17.09 and later, so it's not used anymore. Successor. Its functionality has been largely replaced by built-in Windows 10 security feature, notably by the process vegetation management tool and Windows Defender Exploit Guard. So this feature is not used anymore. It's an old one. Okay, anyway, so I think now we have a clear view about it. So we have an error concerning this one. So we will open Procmon and run it. After capturing, let's use the count occurrence feature to quickly identify errors. tools count occurrence result column. There is only one case access denied result in the whole trace. Let me see what is count occurrence. So I think he's talking about uh, an error and how much count. Let me see this. Let me try to see this feature. So we will go there and we will open Procmon. Let me go to the D and we have sysinternal suit and we have Procmon. Here you go, that's it, and try to open it. Run as. So we'll do like this, okay. So now I capturing a couple of events. So now I have already stopped the capturing of the events. Let's see here the option of uh, tools count occurrence result column. Let's see how this will do. We have tools, and then we have count occurrence, and then he's talking about result. Okay, and here we see, for example, how much success events. Let's count them. So we have 68 uh, 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 68 uh, successful events, okay, 68 times. So this is good. We can count them by column, so we can see we have user, we have a lot of things. We need to count the result, how much success we have. If there is other than success, it also will count it. So we can close, and here you go. We have only one access denied, so we have this one access denied. Perfect. Let's filter for just that result. They examine the single access denied event. The operation was trying to access a registry key for this one under image file execution options. That's a protected key for debugging and application compatibility. Again, a registry key accessing issue. Why would MT need to access that? MT configures exploit vegetation through image file execution options. Let's check what this exe file is. So trying to access a registry key for this file. Okay, so let's continue. Is a part of McAfee data loss protection. McAfee must be using undocumented techniques to protect its key from modification. The solution is to add an exclusion in MAT for McAfee process. They demonstrate adding the exclusion. The count occurrence feature was really helpful for quickly finding the issue in all that data. Okay, this is one of my favorite Procmon features for identifying unusual events in a large trace. So the issue was trying to access this protected key for debugging. Must be using undocumented techniques to protect its key from modification. The switches to add an exclusion MAT for McAfee process. Okay, so maybe McAfee is protecting this key, and this key need to be accessed by the EMET application. So we need to tell EMT to exclude this file of McAfee from its scanning process maybe. Okay, so this is another case. How much time we have? So the missing crash dump. Just wait for a moment, guys. So now we have case 16. Sorry, let's close this thing. The case involved a crash in Windows 2010, Windows Microsoft 2010. Support engineer wanted to capture a memory dump when the crash occurred, but despite try proc dump, no dumps were being created. Why wouldn't proc dump capture the crash? Let's try a test. We will run word with this command to capture a dump on any exception. So we will run this so and so. They reproduce the crash, but no dump is created. Why? A suspected office has its own crash handler that's intercepting the exceptions before proc dumps see them. We need to capture first chance exception instead. So there is a crash handler. Uh, if anything happened to the office, this crash handler records it, and I think he is blocking any other application to take a dump from the program of Microsoft Word. So let's see what's our first chance exception. When an exception occurs in Windows, debuggers get notified before any exception handlers run. That's the first chance exception. After handlers run, if the exception isn't handled, debugger got a second chance notification. So Office is handling the exception internally before they become second chance. Exactly. Let's first see the first chance exception. Word generates normally, so he will put some parameters. They observe the output showing a single access violation exception. Okay, now let's capture the specific exception. So I think he is modifying the parameter somehow. Uh, uh, Capture the specific exception. Okay, that's successful. Capture dump percent. So minus E1 captured the first change exception, and minus F filters for that specific exception type. Exactly. The minus N part limits it to capturing up to 10 dumps in case multiple exception occurs. That's really useful for applications that handle their own crashes but still have underlying issues. ProcDump has many options for capturing different types of issues, memory leaks, high CPU usage, and more. So this is uh, a case, but let me try to explain it also in a simple way because I think it's a little bit complicated. Let's get this one and try to give it to Grok. So we'll copy that and go to Grok, tell him explain this case in layman's terms and include a glossary for terminologies. And then put this one and put this one and tell him like this one. Try to control A and control C and put this, give it to Grok and give it to Gemini and do like that and give it to Chat GPT, even though I suspect his answer will be of any good. Okay, let's try. Again, it seems the answer not to be good. Okay, so let's see the answer of Grok. Here we can see that You are trying to figure out why your car keeps breaking down when it stops working. You want to take a quick picture of the engine to show a mechanic so they can tell you what's wrong. In this case 16, the missing crash dump, something similar to is happening with Microsoft Word 2010. The program keeps crashing. Think of it like a car stealing, and the support engineer wants to snap the picture of what's going on inside Word when it fails. This picture is called a memory dump. It's like a snapshot of everything the program was doing at the exact time it broke. Okay, to take this snapshot, engineers use the tool called ProcDump, which is like a camera designed to catch the problem automatically when Word crashes. But here is the mystery. Even though they set up Procman to take the picture, no snapshot were showing up. Maya, one of the people involved, is puzzled and asks why wouldn't ProcDump capture the crash. Leo, her colleague, suggests running a test by starting Word with special instructions to make ProcDump take a dump whenever something unusual called an exception happens. So why didn't ProcDump work? Let's break it down simply. The crash might not be what Brockman expects. Brockman is set up to take pictures when Word hits a big problem, like an exception. Image the car engine blowing a gasket. But what if the world is shutting down for a different reason? Like if the driver just turned off the car instead of braking it. If the crash isn't caused by an exception, or the world handles the problem quietly and exists without making a fuss, ProcDump might not notice and would not take the snapshot. Permission problems. Think of ProcDump as needing a key to get under the car hoods and save the picture. If it does not have the right permissions, maybe because it's not allowed to look at the word or save files where it wants to, the snapshot can't be taken. For example, if Procmon isn't run with high enough authority like an admin, it might be locked out. Instructions got mixed up. Maybe the engineer told Procdam to watch the wrong thing, like asking it to take a paragraph of a different car instead of the one breaking down. If the configuration, the setting they used, was wrong, like typing the wrong name for word or picking the wrong options, Procdump wouldn't know what to do and no picture would be saved. Something else got in the way. I think this is the last one. Image, another mechanic already working on the car, blocking Procdump from doing its job. This is the correct one. If like other tools like a different debugger or security software like an antivirus are interfering, they might stop Procdump from attaching to Word or saving the dump. Leo's idea to run Word with this command is like saying let's start the car ourselves and tell Procdump to snap a picture at the first sign of trouble. This is probably planning to use a command like procdump -e -w winword.exe, which tells procdump to wait for Word to start and catch any exception. This test could help figure out if Procman is working at all or if the problem is specifically to how Word is crashing. In short, Procman didn't capture the crash dump because something went wrong. Either the crash wasn't the type of Procdump could catch, it didn't have the right access, the instructions were off, or something else blocked it. The engineer need to double check how Word is failing, make sure Procdump is set up properly, and rule out any interference. I think this is the last one is something else got in the way. Okay, let's see if Gemini also can explain it in simpler terms. Let's see this one. Okay, imagine on a program on your computer like Microsoft Word suddenly freeze or shut down unexpectedly. This is called a crash. To figure out why it crashed, technical support people often want to get a detailed snapshot of what the program was doing in its memory right at the moment it crashes. This snapshot is called a crash dump or memory dump. In this case, the support engineer was trying to get one of these snapshots for Microsoft Word 2010. When it crashes, they use a special tool called ProcDump, specifically designed to create this snapshot. The mystery is, even though Word crashed and they had ProcDump running and waiting to capture the snapshot, ProcDump didn't actually create the file it is supposed to. It failed to do the job, and they didn't know why. Investigation. Leo, the expert in the scenario, decided to run a test to see if they could get any kind of snapshot from Word using ProcDump, even if it wasn't for the specific crash they were originally interested in. okay, to take a general snapshot, not a specific snapshot for a certain situation. He planned to start Word using a specific command line instruction for procdump. This command tells procdump watch Word very closely. The instant anything unusual or unexpected happen inside Word, even a small error called an exception, immediately take a snapshot, a memory dump. Okay, this test help figure out if Procdown can interact with Word at all, or if there is a more fundamental problem preventing it from capturing any dump. Glossary. So I think here he has already give proc dump, or he has modified the proc dump to capture the least detailed thing. Okay, and we can see here there is a problem because Microsoft Word has its own crash handler. So this is maybe the case. Okay, so we go to case number 17. So this is the last case, the random sluggish. This user reports that the computer becomes very sluggish intermittently when the mouse cursor constantly switching between normal and busy states. Let's see what's happening in Process Explorer when the sluggish occurs. They observe Process Explorer during a sluggish period. Look search protocol host.exe and search filter host.exe process are constantly starting and stopping. What are these two services? Let's check the event log for any errors related to these processes. They found numerous application crash events for search protocol host.exe. These search-related processes are crashing repeatedly. Let's set up procdump as the system just-in-time debugger to capture dumps when they crash. So we are capturing now a dump. When this happened, waiting for crash to occur, they collect several dumps. Now let's analyze them using Windows Debug. Lee opens a dump in Windows Debug and runs analyze v command. Look at that. It's showing an NX no execute fault caused by a module called EVMSP32. Let's check what that module is by clicking on module name link in the debugger. Debugger shows this program uh, belongs to Semantic Enterprise Vault. This is our caterpillar. The search indexer is crashing because of a bug in the Enterprise Vault component. Uninstalling Enterprise Vault could resolve the issue. So Procdump help us capture the crash dump automatically, and then Windows Debug analyze them to identify the problematic module. Exactly, the combination is very powerful for diagnosing the intermediate crash that you can't easily reproduce on demand. So I think this is case number 17. Can go to case 18. I think we have some time, or I think we can make it 1 hour. Case 18, the AI Explorer begged CPU. Here is a case where Internet Explorer was consuming, again this is now not working anymore, Internet Explorer was consuming high CPU after being closed. How did you spot that if AI was supposedly closed? Process Explorer system tray icon shows CPU usage. Hovering over it revealed that iExplorer was consuming 50% CPU on a dual core system. They demonstrate how the Process Explorer system tray icon shows CPU usage. We have seen this before. When I opened Process Explorer, I found IEE process and checked its threads tab. One thread was consuming 100% of one CPU core. What was causing the high CPU usage? I selected the thread and clicked the stack button. We have seen this before. To see what it was executing, they look at the stack. The code was originating from a component called gpu.ocx. Using DLL view in Process Explorer, I found it was ActiveS controller from so and so from NOS Micros. Okay, so what is used for? It is download manager used by some website. In this case, it was installed during an Adobe Reader download but got stuck in a loop after download complete. How do we fix that? Simply terminated the Internet Explorer process in Process Explorer. The ActiveX control wasn't configured to auto start, so it wouldn't come back unless a website specifically invoked it again. Process Explorer does not help us identify the CPU usage, but also showed exactly what component was responsible. Yes, and the thread stack feature was key point pinpointing the exact module causing the issue. So let me do something here. I will open the Process Explorer. So let me go to Process Explorer and run it. Okay, for example, here you go. This is it. So we have Process Explorer. Here we can see the DLL file and the description of it. So if I go, for example, to any process stack, for example, let's go to any one of these properties and see the stack. Where is the stack? I think something called the stack. Let me remember. So here we go, like properties. There is no stack for it. So there is no stack. There is something called stack. So maybe like for the Avera or update here. I remember the stack process. Maybe the stack it is in. Let me see. He's talking about here. Uh, Selected the thread and click stack button to see what is executing. The stack thread. Here is the thread. And for example, okay, this is, and there he called the stack. Okay. And now we can see the files executed. Okay. So that's good. Okay. And then the threads. Okay. And then you call the stack. The code is originating from okay, like this file. So we open that, we have a file like this. I need to know what this file is about. For example, maybe one of these, for example. So this is the file, for example, win32 full.cs, so and so. So if I close this, if we go to DLLs, we have something called win. So here we can see the description of the DLL file. We can get useful information from this info. Here is the threads. So I think this is a good thing. We can get most information about anything from the threads. So we can get the thread and the stack. The code originating from a component called gp.ocx using DLL view in the Process Explorer. I found that this is this file is get plus so and so. So this is it. So I think we can stop at case number 19, the runaway website. So I think we can stop at that and continue with the upcoming video. Hope this video is informative to you all, and thank you all for viewing. Thank you so much.